Hi viewers, my name is Badrinath, ECE department from Johnson's Institute of Technology. My case study topic is mathematics in roller coaster. Roller coaster. Everyone like that roller coaster. So, what kind of math used in roller coaster? Calculus is used in create and analyze curves, loops, and twists along the roller coaster track. It helps us with slope calculations and find the maximum and minimum points along the track. See, mass behind the roller coaster. And how does the role of mathematics impact the design of a roller coaster? Math is used to measure the stress, the speed of the coaster, the weight it can hold, and what tricks it can be performed. Math is used to calculate how the coaster will be affected by gravity, mass, acceleration, and kinetic force. Mathematical formulas are made, tested, and tweaked until the desired result is achieved. What is the formula for roller coaster? In other words, gravitational potential energy A equal to kinetic energy B plus gravitational potential energy B or mgh A equal to half mvb square plus mbhb. mghb as seen in this equation above. The value of 30 meters is reasonable for motion of roller coaster. How do roller coaster engineers use polynomials roller coaster design? Architects use polynomial polynomial function to help them design roller coasters. Polynomial function equation are used to calculate the characteristics of a roller coaster such as maximum or minimum points, angle of descent, and the thrill of the path of the track. How are polynomials used in roller coasters? An example of polynomial function that represents a basic roller coaster would be f of x equal to minus 0.000833. The graph shows two basic loops that are formed the function and how it would mirror a ride. Polynomial functions can be used to predict the motion of objects. See, how do you calculate the thrill of a roller coaster? The thrill of drop is the product of the angle of steepest descent in the drop and the total vertical distance in the drop. The thrill of the coaster is the sum of the thrills of each drop. Be sure to record the x and y coordinates of the peak and valley points and the slope at the steepest point. Maths behind roller coaster loops. Firstly, loops. This is the main topic we can discuss it deeply. The most exciting roller coaster design contain one or more loops. The loops must be built with extreme caution. A loop that is too circular with require very high speeds. This would result in a g-force that is too high for people to comfortably withstand. A perfect roller coaster loop is a teardrop shape called a clothed loop. In a circular loop, the radius is constant, but in a clothed loop, the radius changes and is shorter at the upper part of the loop that it is across the center. This means the roller coaster car can get through the loop at lower entry speeds. Advanced math functions are used to model clothed loop in computer programs. Calculus is used to create and analyze curves, loops, and twists along the roller coaster track. It helps with slope calculation and finds the maximum and minimum points along the track. And second one is slope. Maximum people knows the slope. Order of complete a loop. A roller coaster car must travel at the right amount of speed. In his speed that is needed is dependent on the size of the loop or turn. Every roller coaster begins with a very high hill. The higher the hill, the greater the potential or stored energy of the roller coaster car. When the car reaches the bottom of the hill, the potential energy has been completely converted into kinetic energy, which is the energy of motion. That's when the roller coaster car reaches its greatest speed. They have to sketch a roller coaster out showing the placement of hills, twists, and turns. Has to make a more technical drawing in a computer aided design program have to calculate the slope of our roller coaster hills in order to construct an accurate model, one that the construction crew can assemble correctly. The slope will allow us to accurately determine the speed that will be generated at various points along the track. dH kinetic energy plus potential energy like I could say, where kinetic energy equal to mv square E square is kinetic energy. Potential equal to mgh z is potential energy. These are the formulas. Here m is mass, g is the gravitational acceleration constant, and z is the vertical displacement from any reference point. V is speed. Since there is no force and no charge, no change in potential energy in any horizontal plane. The content behind this activity. This is the key activity. Listen carefully. To keep roller coasters on the track, make sure to do the math. This activity gives student hands-on experience with several mathematics and physical concepts in the development of safe roller coaster. The roller coaster starts with an initial drop, usually a very high hill. So the coaster gains enough speed to keep itself on the track and to successfully navigate a loop. The coaster reaches its greatest speed at the bottom of the track. In this activity, the student gain experience taking data on track length and run time, and then using the data collected to calculate the average speed for each run. The progression of construction, testing, observation, and evaluation reinforces the irrigation of math and science in the real world challenge of roller coaster design. In a roller coaster, the potential energy that the car has at the top of the track is converted into kinetic energy. Before the car starts moving, all of its energy is potential. When it reaches the lowest point, all of the energy has become kinetic. The equations are potential energy equal to m into g into h equal to m means mass of object, acceleration due to gravity, height of the starting point of the object, and kinetic energy equal to half m square v square. Here half mass of object into velocity of object into velocity of object. Velocity is the rate at which an object changes its position and includes the speed and direction of the object. Acceleration is the rate of change of velocity. Mass is the amount of matter contained in an object. The average acceleration due to gravity on Earth is 9.81 meter per second square. And finally, conclusion friends, math is used to measure stress, the speed of coasters, the weight it can hold, and what tricks it can be performed. Math is used to calculate how the coaster will be affected by gravity, mass, and acceleration and kinetic force also. Mathematical formulas are made, tested, and tweaked until the desired result is achieved. Thank you friends. If I made any mistakes, please leave it friends, and sorry for that. Thanks for watching friends.